Let's work on a few problems involving exponents. So 3 to the 5th. Reminder, an exponent, if you have a to the n, it's a times a times a. You've got n of these. So just like multiplication is repetitive addition, exponents are repetitive multiplication. So when we say 3 to the 5th, it's 3 times 3 times 3. There's 3 of them. There's 4 of them. And there's 5 of them. So 3 times 3 times 3 times 3 times 3, 3 to the 5th is going to be 243. The square root of 4 is an exponent. Let's first rewrite it. The square root is the same thing as to the 1/2 power. So 4 to the 1/2 power, that is going to be 2. Now, if you have an equation where you have x is equal to 4, actually, let's say x is equal to, let's say x squared is equal to 4. If you have an equation in which you introduce a square root, then you have to consider two different answers, plus or minus, because minus 2 squared gives you 4, but then also 2 squared gives you 4. But in this case, we didn't have to introduce the square root ourselves. It was given to us. So anytime you take an even root, then you elect to take the positive answer. So we're not going to take plus or minus 2. We'll just take 2. So the square root of 4 is equal to 2. Same thing, 4 to the 1/2 is equal to 2. Here, 9 to the 1.5. I'm going to rewrite this as 9 to the 3/2. 1.5 is equal to 3/2. I'm then going to use the fact that I can iterate my powers. So instead of taking 9 to the 3/2, I can take 9 to the 1/2 first, and then raise it to the 3, right? Because whenever I iterate these powers like this, then I multiply them and I get 3/2. And the reason that I did this is because now, initially I might have needed a calculator, but now I don't need one. 9 to the 1/2, that parentheses is just the square root of 9, which is 3. And now 3 cubed is 27. All right, finally, the cubed root of 81. Let's rewrite that as a power. That's 81 to the 1/3. So on top of the square roots, there's kind of like an imaginary 2. So the cubed root is 81, or sorry, the cubed root is something to the 1/3. And 81 to the 1/3, this isn't going to be a nice answer. It's going to be a decimal that never ends. It's going to be approximately equal to 4.327.